Hi, can you hear me now? All right, so let's get back to what we were doing here. So the next thing we want to do is we want to take up this command. We want to take up this command and run it. All right. So okay, and note the slashes at the line and line. If you want to put everything into a single line, then we can remove slashes like this. Okay, and then put it in a single line. All right, but it is actually better if we, for the demonstration purpose, that we put this way. Okay, now have a look at this. What are we trying to do here? We are basically executing this command. Okay, let's see what error do we get. Okay, let's have a look at, does the input folder exist? Hadoop fs minus ls. That's asgiri is my folder in hdfs. So the input folder has one file called big.txt. Okay, it has one file called big.txt. You can have a look at it. Asgiri, word count, input, and big.txt. Perfect. Now let's see if the output folder exists. Okay, Hadoop fs minus ls, and that's my output folder. Okay, so let me, yeah, all the files it will take from the output folder, input folder. Okay, asgiri, word count, and then output, and let's see what happens. Okay, so all these folders already exist. Now I want to do the 24 Jan. All right, that is sure it doesn't exist. So if you see in this one, it immediately gave an error earlier that output folder already exists. Okay, so that's why we are giving another output. So output folder, let's change it to something like this. Okay, in asgiri, word count, and this one. Perfect. Now if it has multiple files in the input folder, it would take them also into the input. Okay, now as soon as any MapReduce job starts, it gives you a URL to track back. Okay, track back the progress of your work. You can have your own streaming jobs, yes, of course. That's the whole idea about your own streaming jobs. All right, and probably running your own streaming job is the quickest way to do a lot of data churning without writing a single line of code. If you note, we did not actually write a single line of code. And you will appreciate this fact when I would be discussing how do you do MapReduce in Java, right? So here we are basically using these basic Unix command to be executed by this hadoop-streaming.jar library. So there is no way you can overwrite the output directory. That is something which is by design, but it doesn't hurt you to actually, you know, delete the directory before you start. Okay, so if you want to delete the directory before you start, you can say fs rmr, and this is your output folder. You can do this way. Okay, all right, so that was the question from Sahu. And yeah, so this is the job which is running, and for each job what we have right now, there are two maps and one reduce. Okay, so if you can see the map, it says that each map has got two tasks. Okay, this map has got two tasks, because it has got two tasks running, and both have succeeded. All right. Now, in case your job was printing any output, you could go to each attempt and you can see that when it tries to execute the first attempt, there was an error. Okay, you can look at the error. What does it say? It doesn't say anything actually. All right. And this is the second logs. And here you say. So in case your program is outputting something, printing something, it will come here. All right, it will come here. And these statistics are of very much use. Also, once your process finishes, it it gives you the details of every all the statistics as an output. Okay, and it also shows you the maps and reduces. All right, I wouldn't bore you with the details right now. When you run your own command, okay, you can have a look at all of this. Now this folder has been created. Okay, this folder has been created, and you can see that there is something called, let me increase the window size a bit. Now it's better. Now there is a zero byte size file called underscore success. It is created once the process finish, and there is another file in the folder which we gave as output folder, is part 000. Basically, for each reducer, if there are only one reducer, then there will be only one part. If there are multiple reducers, there will be multiple parts. Okay, so Hadoop fs minus cat, and we do this. So you can see that it has done a marvelous job of counting the words. Okay, but there are few things. If you basically now want to sort it again, you can either use a local machine command, or you can write another set of streaming job to take this as input and then sort this data by numbers. Okay, okay. Now, now you, those who are, yes, every time this map reduce actually writes the file name as part 00, part 01, and so on. All right. Now we have got, okay. So that process is running. Okay. Now, as you notice that if you have to combine parts files manually, do we have to finally do we, okay, so we have to combine multiple part files manually or with some command to we have final sorted output across all. So see, the important aspect which you should notice is all of these parts are actually sorted files. Okay, and the key the important aspect is that the data that goes into these reducers is actually you know uh, well separated. If you concatenate, simply if you concatenate the two files, part 1, part 2, or if there are 5 files, you just simply concatenate them, you will have the sorted output. Okay, if you simply concatenate, and Hadoop gives you a beautiful command for this. It says get merge. Okay, so you can give a multiple files onto get merge, and then you can get it locally. Okay, remember this is local file. All right, it's a local file. Now, all right, this is a very good question, Abhinav. So give it one more attempt. All right. Now, first attempt is that whenever whenever we have so this is a very common question. Question is that how should we concatenate? Okay, concatenate. It has multiple aspects. First, why should you concatenate? Okay, right? Mostly when you are dealing with the output of MapReduces, you would not need to concatenate the output of MapReduce. Okay, you don't have to in general. Second, a cat simple cat will do the job. Okay, the only downside of a simple cat is that you will have to download the files from the Hadoop to local machine, then push it back, which is not a great practice. Okay. Now, mostly, as you saw that when we were dealing with Mapper, we simply took the output from a folder. Similarly, you can do in case of MapReduce as well. You can simply specify if you have a second phase of MapReduce, you will just take it and do it. Okay. So either cat or get merge will do, but you will have to take it out, take it out locally, and then put it back into HDFS. All right, that's the downside of this approach. So mostly people did not face that kind of a problem of trying to merge the file. That's whenever we think about the way we have been dealing with file, we think it that way. All right. Now, as we saw in our output, there were a lot of special characters. If you see, they were hindering the way we should be counting the words. All right. So now what if we want to go a little bit more sophisticated? Say we want to remove every non-alphanumeric character and also remove the empty lines, right? Because we replaced each space with a new line. If there are multiple spaces between words, that will become blank lines. Now, if we have to do that, instead of simple SED, we might have to write something of this sort. What does this do? Let's go from left to right. First, we replace spaces with new line. Okay. We can also say plus spaces here, or yeah, plus spaces here with new line. All right. Then what we do is whatever output is generated, we replace the non-alphanumeric character with nothing. We just delete it. Okay. And then we translate uppercase to lowercase. Let's have a look at what happens when we actually run it. Okay. Now let me just say echo hi, and then I say hi capital 1 2 comma 2 3. Okay. Now what happens here is, right, right. So basically we are able to remove the special characters, convert everything into lowercase, and the bingo, we have this. Right. Now if we have to run such kind of a complex command, it's basically a Unix pipeline. From left we replace we replace space with new line. Okay. Then afterwards we replace non-alphanumeric characters with nothing. We just delete it. Next is that we translate the uppercase to lowercase, and that is happening when like a pipeline from left to right. Okay. Like for example, if I have to just comment down the code and see what is going on, let's see what happens. Let me comment out from here. Right now you can see that the space was replaced with new line, but nothing else happened. Now let me comment out from here. This is for those who are not very familiar with the Unix pipeline, but this is very important whenever we are dealing with any kind of big data. Trust me, you are going to use Unix filters. Even if you are going to use Windows systems, most likely, most likely you are going to use something like Sigwin, which is all of these commands ported to Windows because they are very handy. And now next step, I have commented out my translator and only the replace the space with the new line, and we replaced non-alphanumeric character, that is comma, with nothing, and then we can enable our translate. You can see that. So we translate everything into lowercase. So this way we'll get a better output as compared to a previous attempt. All right. Now how do you do that? Now problem is that you cannot specify this as a mapper, this whole command as a mapper right away. Instead, instead you will have to put it in a file and also put this at the top, as well as do a chmod plus x, make this mycmd.sh executable, and then send it to the mapper. Okay, now let's have a look at what's going on here. So we already would be having mycmd dot, okay, ls my. Yeah, you can see that it has got all the execution permissions. All right. And what does it have? It has whatever we wanted to put. Okay. N- That is one way to deal with it. Now reducer is same. We haven't changed anything in reducer. Reducer is simply a counter, which basically counts the unique words in a sorted input. Okay. Here, as you can see that input, input, output. Good. Now we have, all right. This particular option I would like to explain. Now, why do we need to say minus file mycmd.sh? Why? Why didn't we say minus file? Why didn't we say minus file user bin unique? Right? Why? Because user bin unique exists on all of our nodes. Okay, this user bin unique exists on all of our nodes, while mycmd.sh does not exist, because that is something which is quite local to us, right? So this mycmd.sh has to be put into something called a distributed cache of Hadoop so that it can be executed on the data nodes, or you can say task trackers, right? Because whenever task trackers will be executing these commands, they will need this file somewhere. Either it should be present in user bin or somewhere in the path, or it should be copied there. Okay, so that is why you need to specify minus file option to any script you want to run. Okay, now let's put slashes. The slashes make it look good. Sounds good. And also let's just put 24 Jan and 24 Jan, and we call it 1. All right. So it's starting the process now. Input is same. Output folder we have because either we delete that folder, we don't want to delete that folder, or create a new one. And this is our task tracker URL from where we can track our job, what's going on with the job. Are you with me? Great. Nakul? Swati? No? All right. So everybody's with me, or have I confused you? Or have I put you to sleep or something? Okay. So you can see the process of this thing is going on, and sometimes the tasks fail and it attempts again. Let me refresh it. What exactly happened here? All right, so we have got maps to reduce one. And if you want to increase number of reduced tasks, you can specify from the command line argument. I'll show you that. Okay. And we have got maps to. So both the tasks have succeeded. All right. And the output directory is here. And this time, if you say Hadoop fs and minus cat, and we say more. So you can see the data is fairly cleaned up. Now, a better thing to do here would be do a sort minus nr. nr, basically I want to sort this using a local command. And be aware that this is not a great thing to do. Now you can see that in the input, in the input, we have the, of, and, to, in, a, and all of these commonly used words. Okay, we have got these commonly used words, right? And after that is somewhere, let's have a look at closely. Somewhere there is a uncommon word prince and an uncommon word Pierre, right? Which means it has something to do with these two things. And there is somebody called Natasha who has come at least 1093. So if you remove these commonly used words across all the books, you will be able to figure out what this story revolves around. Okay, just the word count problem actually can solve a lot of things for you. Okay, it can give you a great insight into the book. Okay, and if you have been following Amazon, so we had this feature in our books at Amazon. I still call it V. So at Amazon they have a feature called how does character, how does one person comes into the book and where do those characters get introduced. Okay, it was based on a simple word count. Okay, all all we did was we did a word count, removed the commonly used words from the input, and then at the end of it we had various characters, and then we see that when these characters are coming into books, and then we just color it. So basically the word count itself is a good point to start with into data sciences and into data analytics. Yeah. So, okay. So the input file is our this one. Okay. Let me just also give you. So Hadoop fs minus ls. This is our input folder. So our input size is these many bytes. Okay, which is around 6.5 MB effectively. It's a very small file when we are talking about the big data. It's a very small file. Okay, now let me. So Susan's question is how big the input file can be. So answer is as big as your cluster can handle. Okay, if you have got 1,000 terabyte of cluster, you can actually handle a 1,000 terabyte big file. Okay, that is the beauty of having HDFS into place. Because I have dealt with pretty big files, like maybe uh, half a terabyte file. Though I have dealt with the huge data, but most of that input folder contained all these files, but they were in a different folders and different structures. Right. Now let me answer Megha's question. Can you explain mycmd.csh details again? What all locations we can use this file? Can we have one? Yes. So of course the mycmd.sh is only located locally. Okay. This command file this option of streaming job pushed took your mycmd.sh and put it on all the nodes. Okay. So you don't have to copy by yourself on all the nodes and make it available. So Julie's question is, how would you break a file that is too big into smaller file into small? So there's a command called split. Split to do that. Okay, you can specify that these are the file. Uh, this is how it is, right? Or you could write a simple uh, job. What it does is, which basically reads the input file and puts it output, and in the reducer you just mention that I have 20 reducers. Okay, so what will your reducer do is nothing except that whatever input is coming, it just moves it to multiple files. Okay, so I'm trying to answer Julie's question. In case you want to split a file, first you would not need to split a file in HDFS. Reason being that file is anyway splitted by HDFS for you. So the more smaller file you have, HDFS will crib more. HDFS will not be very happy if you have more small number of files. Why? Because it will take too much of space on the name node. All right, and you will quickly fill up your name nodes memory if you have too many smaller files. If you have bigger file, name node will have only few entries. All right. In case you have a smaller file on the Unix side, on the local file system, split command will do the justice. Good. Sahu's point is currently we have 100 terabyte of data in mainframe. Can we migrate that to HDFS and use in real-time approach as a database? There's no limitations to this approach. The I will be very rash and very quick, Sahu, that just use a dist copy or a flume or maybe a scoop kind of architecture to push this data from your mainframe into HDFS. And if your data is structured, if it's in database format, use HBase because you want to use it real time. Okay. because HDFS is not very great if you want to do thousands of write operations. All right. So okay, great. Now moving on. So Julie, was I able to answer your question? Okay, Abhinav's point is, so if we want to have combiner after mappers, we have to write our map reduce in Java only. Is there any option in streaming job to have combiner before the mapper output? Yeah, so if you have a look at, okay, a better thing would be just hold on for a few seconds and we will talk about that. All right. Now there is something, an option called, you can specify number of reduced tasks. Okay. So here the way we have done our work is this. Let us let us change the output folder's name and try with different number of map tasks, reduced tasks. Okay. Let me understand what's going on. Okay. All right. Now let me see if it works. Let me see what's going on. So here I'm trying to put two map reduce tasks. All right, let it go. So there are two map reduce, as you can see now. Earlier it was only one. Now there are two reduces. All right. And also if you, now this is done. All right. Now there is a command called combiner, just the way you have reducer. You can specify that using an option called combiner. So So that was Abhinav's question. So you can actually specify a combiner the way we have done our uh, a reducer. All right. Also, the partitioner also can be specified. We'll talk about all of these in detail in this session or the next session whenever we get a little bit of time. Okay. All right. So if you want to see more syntax about streaming job, you can go to this URL which is mentioned and then start working. All right, but this should give you enough of confidence that streaming jobs this is how you run a streaming job. Okay, so you can see now what I actually wanted to show you is this. Now you can see that under this there will be three folders. Now one is for marking that it is successful. Second, there will be two files, these two files you can see, part 0001, part 0001, 000 and 001. And that's how, so there are basically these two parts in which the work is divided. Now let's have a look at So let me just go to here. As you can see here that it starts with a key called 005. This is the count which is in the beginning, because unique minus c gives count in the beginning of line. 005 is where the first part starts, and it ends with something like this. Now let's have a look at what does the second part contain. Okay, I too am curious to understand what is in the second part. All right, so you can see that both the parts are not really the way I had actually expected. Okay, okay, both the parts are not really the way I had expected. They are essentially, you'll have to, if you have to combine these together, you will have to actually sort them again. Okay, so my mistake. Streaming job doesn't, the partitioner in streaming job is not doing the way we had expected. So the default partitioner is the one which decides how is the data partitioned. So data is not partitioned in a way that it can be joined straight away. Okay, so in case you want to create partitions such that the data can be joined easily without having to sort, that is easily possible. I'll show you that in the next session when we discuss partitioner. All right, so the default partitioner doesn't partition the data in case of streaming job such that if we concatenate part 0 and part 1, we get the sorted output. Okay, but it is guaranteed that a key cannot exist on both the sides. All right, a key cannot exist on the both the sides. Though the words, the keys which have gone into part 0 will not go into part 1 and vice versa. Alright, so okay, so my mistake, I take it back. Abhinav question is that actually I wanted to ask, in streaming jobs, will the output of mapper be in this format key comma CSV value? No, it will be just sorted keys, you are right. Okay, so output of the mapper will not be a sorted keys. Output of the mapper will be key, then followed by a tab and then value. Okay. Key followed by a tab and the value. Or if you don't want to specify anything, don't put a tab or anything. So anything, if you have this line and then at the end of it there is tab. So this is the key. Okay. This is the key. Now the output of the mapper is going to be something like this. If you have say k1 v1 k1 v2, so this is what is going to be the, and then you have k2 v1 and then again k1 v1. So this is what your mapper is going to give out. All right, now after Hadoop receives it, it is going to sort of, sort it and then send this to one reducer and send this to another reducer without combining them. It'll send it as such. Okay, now it will be up to your reducer. You can actually see that your reducer can itself do the combiner job, do the job of bringing all the values together, it's actually pretty straightforward. Your reducer, all it has to do is start reading from the top, keep on reading till it hits a different key, and so on. Okay. So the formation or grouping of the keys is done by your code. It is not done by streaming job. That is the difference between our standard MapReduce or this one. All right. Now let's start the discussion. So is this streaming job is clear with everyone? So and also the default partitioner, which is different. I mean, sending some keys to one part, sending other keys to other part, meaning other reducer. All right, great, great. Now let's talk about the frequencies of letter A to Z. Yeah. So actually, why I have talked about streaming job first, so that you get more control, you start experimenting more as compare, because people who are writing code in Java, they will have this inertia to actually write, compile, upload, and then try to run it. Okay. But if you are happy and okay with the Unix commands, you will mm, be able to run it. You will be able to experiment it right away. All right. So you can start working on this. And also whenever you are churning the data, say you have to just lowercase your input, it will be easier to do it in streaming job rather than writing everything from scratch. And lots of people who write, and also I forgot to mention this. Now here, as we said, any command, it could be any binary. It could be your Python program. If you want to run your Python program, what you got to do is, say you have a simple Python program here. Okay, you just put hash bin Python here before this and make it executable. All right, and that's all. So see, most of the Unix, when it starts executing a script or command, tries to figure out how to execute a binary based on the first line of the program. Okay, based on the first line of the program. So you can actually execute any script using MapReduce, a streaming job. Good. Now moving on. All right. So who wants me to take a look at his answer for this question? Frequencies of letter. Seema, Abhinav, I think you guys have done. Okay, the chat log is gone. Okay, let me have a look. So I'll also have a look at Abhinav's. Let me open it in separate windows, okay? Who else? Abhinav Megha. Why can't I? This one, okay, great. Now let me just have a look at it. All right. So this is Seema's. If the test file is few gigabytes, good. We don't need MapReduce, yes. But if the data is in terabytes, then you need to have MapReduce enough. Though an array be size 26, the reason being the sheer volume of data, we can split the data in few data nodes, okay? And in the map, we can process the chunk and then in reducer combine all the data. Data node 1, yes. Data node, perfect, okay. Yes, and perfect, perfect. Okay, and yeah. Good, good. This is better. This is good. This is good. So, okay. All right. So basically, this is what Abhinav Abhinav has written in the code what Seema is telling here. And let me also have a look at this. Okay. Perfect. Perfect. All of you are right. And so basically, yeah, basically the answer to the question is that if the file is of few gigabytes, we don't need MapReduce. Why? Because you can actually read it, and rather than transferring the file over the networks, you can actually process it faster on the local disk itself, right? But in case the file is already available on, because if you have files in terabytes, definitely you will not be using a normal system. You would be using something like a distributed system. So okay, good, good. So that's good answer. Yeah. Abhinav's question is, time taken to complete the job will also depend on which binary are we using. So the difference between execution of a Python or a Java program or C binary is in terms of milliseconds. Okay, and that too once that script is loaded into the memory, the difference is only in few milliseconds. Now when you are running systems across the cluster, the chances are that your overall job is going to take quite much time, maybe 10 seconds, maybe 15 seconds, or maybe an hour, right? So the difference between programming language to programming language is going to be very insignificant when it comes to churning the data using MapReduce. All right, good, good. Abhinav, was I able to answer your point? Now, so good. So frequency, correct answer of the frequencies is that if your data is in few GBs, then you don't need a MapReduce or Hadoop. You can be happy with your traditional approach. Have we discussed it? No. All right. So without MapReduce approach, the answer is fairly easy. You basically take all these numbers, create an array, scan text character by character, and then for alphabet A, you increase A0, and for alphabet Z, you increase A25, and others in between. The only downside of this approach is the memory or RAM will basically here, if you see, the RAM is not really limitation, but your network and disk IO will be the bottleneck. Okay, and CPU will be the bottleneck. All right, now have we discussed this earlier in the last session, last class? No. Okay. All right. All right. Good. So in case of MapReduce approach, it does the same thing as previous example on each of the node. All we are doing is we are counting the frequencies of each character. Okay, each mapper is doing it, and the reducer will sum it at the end of it. All right. So basically, each of our mappers is going to do this job what without MapReduce we are going to do. So basically, in case of each of mapper job, we will do for a whole line. We'll go from left to right, and we'll count the frequencies of A, B, C, D, and then print it in the output. And similar in the case of mapper number two, and then we combine everything in the reducer. Okay. So is this clear or did I skip a lot? So just let me know if this approach is clear or not. So all we are trying to do is the way we did word count, we did word comma 1, word 2 comma 1, and so on, right? As a key value. Key is the word and the value is 1. Here the key is character and the value is 1. That's the output of each mapper, right? So when we go line by line, when I say here, it is not going to take time. It is definitely going to take time, but not the memory. Reason being, the only thing which we are retaining in the memory is this array of 26 size, right? It is definitely going to take a lot of time because of the disk. When you read from the disk, it takes time. And so to eliminate that, we'll go with our MapReduce approach. In case of MapReduce, each of the mapper will be given each of your mapper code will be given one line at a time. Okay, and your mapper code will have to convert this line into the frequency of characters, right? And that frequency of character will look like this is the mapper one's output, this is mapper two's output, and as a reducer you will basically sum it up. Reducer will get this as input and then it will sum it up, right? Now the second question, who got the second question correct? Anyone? All right, now let me go to second question. Okay, let me check Amit's. uh, Amit, what is your email? First few characters of your email ID. Why can't I see this? Why can't I see? Is it on the second page or something? Actually, can't locate yours. So basically, okay, okay. Excellent. This is good. This is good. This is Abhinav. All right. Now this is Seema. Now let me see. Excellent. Excellent. All right. So what we are trying to do is just sort and print the letter that matches. Okay. Okay. Inside the map function, this is what is going on for each word in the input. Okay. And for each letter in the word, if letter is between A to Z, print letter sort and okay. That is the first one. Sorry. I'm not looking at the first one here. Go through the words. Okay. So the idea is to convert the sorted characteristic. So excellent, excellent. So you all got it correct. Now let me explain my approach. My approach is exactly what you have done. The idea is that whatever input line you got, you take each word one at a time and sort the characters, and that sorted characters string is what you make it as a key. For example, and the value remains your actual word. So your actual word is the, you sorted the characters, so EHT is your key, and the value is your actual word. So this is basically two column format I'm talking. The first column is key and the second column is value as being printed out by mapper. Mapper takes one word at a time, splits the line by spaces, picks up each word, and then for each word it sorts the characters and then does the job. Okay? So great, great. So this is the first session in which actually 4 or 5 people have finished this question. Generally, there are 1 or 2 in the sessions who actually finish it, but this class is probably the most brilliant one. Although this is the smallest class I have ever had. All right. So okay, great, great. And here as you can see that all I did was I sorted the characters and here we are. Now why did I sort the characters? So that we are basically trying to find the anagrams. Okay. And what does it mean by anagrams? These are the same characters in different words which are arranged in different orders. Okay. All right. So this is what it is. Now, after this, this line which is there, basically this is the act of Hadoop which converted our input into sorted one, and after that it grouped it, and here we are, right? For each key we have got these values together, right? Meaning the these are our anagrams. While all those who have only one value are basically they don't have any other anagram. Okay, so is this clear to everyone or should I explain again? Please feel free to shout it now. So everybody is clear? Okay, the last part is basically the reducer is actually doing nothing. Okay, reducer is doing nothing. The main job is being done by the mapper, and the main job is the selection of the key. We need to select a key such that all those words which are anagram of each other, they have the same key. Okay, the mapper's duty is to find a key, okay, such that the such that the anagrams could come together. Okay, let me see what others approach I can come up with. Okay, so we could, I let's say my mapper does the key computation as follows: sum of sum of all the letters of a word. Okay, so do you think it's a good approach? If our key is this, will it be good? And why so? Why it's not good? Okay, one is time consuming, but do you think it is logical? Don't you think, don't you think AD and CC will have the same value, right? Yes, that's right. Right? So this is bad approach. Now, if we have, let's say another approach is our key is say, I mean hash code. If we keep hash code, then also we'll have problems. Okay. Now, if we do this from the left to right, 10 to the power the position, okay, of the character into the ASCII value of character. Okay. So we go from position 0 to n, and we keep on reading the characters from left to right, and we keep on multiplying it by this value, 10 to the power position into ASCII value. Will this make sense? Of course no, right? In this case, anagrams are not going to come together anyway, right? So the best approach here is we all want is find all the words which are the same set of characters, and to find the same set of characters in a different rearrangement, you just sort them together so that they all form the same key, right? So that's all is the logic. Sahu? Yeah. How about summing up of the ASCII values of letters? That's what I'm saying. So if we say our key is sum of all characters, right? Let's say this is our statement. Now, AD it will be equal to CC, right? These are not anagrams, right? And still they will come together. Because if you see, AD is what? ASCII value of A plus ASCII value of A plus 3. Sorry, I think I'm messing up. B, C, D, right? And this one is A plus, I think, 1 plus A. Okay, so it'll be equal to BC. So AD will be equal to BC if you think about it. Right, Susant? Good, good. All right. Now moving, everybody is clear about anagrams problem? So someone of my student went for the interview, and they asked him that what is a basic example of the map reduce you can give, which is not a basic example of map reduce, which is not a word count. And apparently that's a difficult thing, but he gave an example of anagram, and he gave example of other things, so it went pretty well. And 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 luckily he got through, reason being that we have discussed so many map reduce problems. And yeah, so it's important to go through these problems. If you haven't gone through the problem, please go through the problems. It will be important, not only in this but in future also. Once gone through all of these problems, then if you go through a problem like matrix multiplication, it will be okay for you. Okay, it'll be okay for you. It will not be impossible or very difficult for you once you go through these examples. Okay, so the overall objective is whatever things we want to operate at once, we want to bring them together. And key selection is the key, is the trick which we need to play. In case of matrix multiplication also, all the values which we want to multiply together, we want to bring them together first. And we will trickily we will figure out what are the keys, such that all those things which need to be multiplied together need to have the same keys. So those kind of things you will understand, you'll get into your guts if you try to solve these problems. Now, awesome, awesome. I look forward to see you, Abhinav, and create a forum thread and post it there, and then I'll also see, because I have built a good amount of framework in which I can test your matrix multiplication on the cluster. Okay, so post it on the forum. Other people can also take a look, and then I can also do a quick test. All right. Now, the next question, this is probably the easiest one. So, everybody got it? Third A, I think I discussed it last time. So, do you want me to explain the third A question? Where a file contains the DNA sequence of people, and we have to find all the people who have same DNA. Okay. Now, so should I explain it? Yes? All right. I think good. So, everybody is good with the third A? Feel free to ask. I'll be happy to explain again. No issues. All right. All right. So moving on to the next question. And let's take a break of 10 minutes. Probably you guys need a break of 10 minutes. Okay. All right. Hi, I'm back. Great. So probably everybody's back. All right. So let's start with another problem. Let me have a quick look at this one. All right. So the problem statement, let me explain again. A file contains the DNA sequence of people. Find all the people who have the same mirror image or who have same or mirror image of DNA. So ACGT and TGCA, these two are mirror images, and user 1, user 2, and user 4 are basically belong to the same group, and user 3 and user 5 belong to the same group, and user 6 is different. So basically there are three groups. Now how do we form these groups? Using MapReduce, because the data is going to be in terabytes and we want to group these users together. All right. So so basically, right now, what have you done in this? Okay, here it says, okay, good, good. So the first one is minimum of the DNA or the reverse of DNA is our problem. Okay, minimum of DNA or reverse DNA. Good, good. Will be our key. This is our key. Okay, okay, okay. The second answer, the first one was the Avinav. Second one is with the addition. So hey Amit, did you submit it online? I think you have not submitted yet. That's why I can't see it. If you submit it, then I'll be able to see it. I think that's the reason. The addition I'll make is from reversing the gene and checking if the pair exists. If it exists, then add it to the same pair. So see, the checking for the pair is something which you need to be clear. You cannot check the pair exists. Okay. So there'll be two checks. Check for ACGT and reverse of this. So question is, what will you keep as the key in your map? Okay, I forgot whose answer is this. Okay, so here, all right. Now third answer we have is, so Seema's question is, can't we keep anything, whatever come first? Mm-hmm. Mm-hmm. What does it mean? Yeah, that's what you have to do. Basically, your point is that whatever comes first, either of the DNA or the reverse, we should just keep either of that, right? That's what your point. Yes, yes. So compare it with what? First, take a new value from the list, compare it. So remember that in the mapper, you will be given one line at a time. Okay. You will not be given the whole input at a time. Why? Because the input is too big to handle, to be handled by single node. All right. So only subset of the input will be given to your node, and out of it, for each of the line, your code is going to be executed. All right. So yes, here we'll apply the same kind of logic as anagram. No, actually. No. All right. All right. So yeah. So the answer is good. Two of you have done it correctly, and here is the way we do it. Okay. So basically, our objective is to bring all those users together who have either identical DNA or inverse of mirror image of DNA. That is the objective. All right. That is the sole objective. Now, what could we do such that all those people who have either same DNA or the reverse can come together? We basically take a DNA and its inverse, and whichever is smaller, we keep it. We keep either one of it, either smaller or the bigger. If you want to keep bigger, we should keep bigger for all. If you want to keep smaller, we should keep smaller for all. Okay. So our logic is find. Basically, we want to form a key which is either DNA or its reverse. Okay. Which is smaller of the two. You can also keep it bigger, or you could also keep it. There could be like three solutions. Key could have been key could have been my in the first solution. Number one, smaller of the DNA, and the reverse of DNA. Okay, whichever is smaller. Or second answer could be that bigger out of bigger out of DNA and the reverse of DNA. Third could be sort sort the array sort the array containing DNA and reverse of DNA, right? So this way you will have sort and concatenate. So these are the three strategies you could use. There could be multiple more if you give it a thought. Okay, right? If you look at the example which we are talking about for ACGT, the reverse of ACGT is what? Reverse of ACGT? Reverse is TGCA. And which one is smaller? I'm just keeping the smaller one, ACGT, right? Now let's pick up the next one. This one, the reverse is ACGT, and the smaller out of two is ACGT. And let's pick up the next key. So for this, the inverse is going to be TGCA, and hence we have ACGT. Can anybody suggest any other approaches than these three? All right. So if you notice for this, the answer is same, right? The key is same, and the value is going to be the user, and therefore these users will come together who have either identical DNA or mirror image of DNA. Okay. As you can see here, after here, this line is basically what Hadoop will actually do for you. It will sort them together, and bring the keys, bring the values for a same key together, and there you go. Here we have this, right? So is it clear to everybody? Should I move ahead? Yes? Feel free to ask again. It's because this is not as straightforward. This is basically for the usual developer. This is little awkward. Okay, this sounds like a big constraint. Or do you have any other approach? You could use any of these approaches. Okay, so for this is clear. This one, the third approach. Let me explain third approach. So for third approach, the key will be ACGT and the reverse of it, TGCA. Okay, this is our key. Let's say this way, and then we'll have this one. Same will be the key here. Basically, concatenate, sort and concatenate. Okay, DNA and the reverse of DNA. Concatenate them such that the small of them is coming before. Okay, okay. Now, the problem with Sushant's approach is, in that case, that doesn't solve our problem. That in that case, user 6 as well as user 1 and user 2 will come together. It is AGCT, right? So user 1, user 2, user 4, user 6 and user 7. All of these are going to come together. Yes, we want mirror, not anagrams, right? Anybody else? Is it clear? Feel free to ask if there's nothing wrong in asking, because it's not, it's little twisted logic. Okay, it's little twisted logic. This is not how we develop, how we code in general. All right, great, great. So everybody got it? Awesome. Now I want to see the next problem. Who has done the next problem? Okay, here we have to simulate the joining of table list 1 and list 2. This is just a guess. From the list 1, the dataset might be AC, BC, CF. From list 2, the dataset might be A5, B1, C1, and joining the first two lists in a combiner C51. Okay, okay, this is quite close. This is quite close. Okay, awesome. This is good. This is good. Great. Now the problem with the next approach, this approach is not great. The first approach is, okay. The problem with this approach is your, um, yeah, the file size will be huge and you cannot look up straight away. Great. All right. All right. Great. Now, so finally somebody has done it correct. You're very close actually. All right. So this is one of my approaches. The objective is, you have got list 1 and list 2, And what do you want is list 1 contains who voted for who, and list 2 contains what is the worth of each individuals, which need to be summed up in order to evaluate the vote count. We are not counting each vote as one. Instead, we are counting as the weighted sum. Okay, weighted sum. The weights of each individuals, we sum it up and form the next results. So list 1 is this, list 2 is this. When we join list 1 and list 2 together, it will not lead to this one, but we want the output as this. C was voted by A and B. The worth of A and B is 5 plus 1, and hence C is 6. And A was not voted by anybody here, therefore A's worth is 0. B was voted by A and A's worth is 5. Similarly, F was voted by C and C's worth is 11. Therefore, A's vote count is 11. Now, how do we solve a problem like this? If we had a simple tables in database, if we had a simple database table, list 1 and list 2, we could have just said select, we could have just said join list 1 and list 2 on the basis of on the basis of on the basis of the voter. And once we join these two tables, list 1 and list 2, then we group by the person and do the word count, right? Then we group by the person and do the vote count. A person can vote twice, yes. So imagine here that A can vote for C only once, but A cannot vote for C twice. All right? That's a very good point. For the sake of question, let's agree that voter A is voting for somebody only once, not twice. But A can vote multiple times to multiple people, right? A can vote to C, A can vote to B, A can vote, and A can also vote to A. Let's not take that case here. Let's assume that all such cases where a person is voting to itself are removed, as well as, right, A is voting to C and B. Yes, that is possible. But A is voting to C, again, the second line contains A is voting to C, that is not allowed, right? And also, C is voting to itself, A is voting to itself, that case is not allowed yet. And that will actually make a very good question, that how do you remove that duplicacy? But that's actually it's not that difficult also. All right, so anybody, one person has solved it. Now, right, should I go ahead? All right, so this is a standard joining operation. And and when we talk about joining in other languages, which in under the hood convert their logic into MapReduce, you will remember that this is how they are also doing. Okay, now we have got two lists, list 1 and list 2. Okay, and in the first attempt, all we do is we just concatenate these two files and make the first column as the key, right? Here the key is AABCBC, and here the key is ABCD. All right. Now, when we get the results, we have this in place. Okay, we have this in place. Meaning, for a value A, we have got the full array containing one of the element is the worth and rest of the elements is who voted for who. Okay, so A voted for, basically if you see, we have concatenated these two files and then fed it to Hadoop, and we have basically the first column is your key. So A has got 5 worth and A has voted for B and C. This is what this line says, right? You can say, okay. Now, out after this, in the reduce phase, all you did was you traversed the values and then printed as the key like B5, C5, A0, right? Basically, you iterated the array saying the worth of B is 5 by virtue of this operation, worth of C is 5, and worth of A is 0. Let's ignore this for some time, then we will fix it again. Okay, just for the sake of simplicity. All right. Now, basically this, when we brought the value of A together with the people who have been voted here, in the reduce phase itself, we break it down the output in this format. Okay. By virtue of A voting for B and C, B got 5, C got 5. By virtue of B voting for C, C got 1. And by virtue of C voting for F, F got 11. Right? And hence, and hence we can see that now once the mapper does nothing in this case. Again, when in the reduce phase, second reduce phase, you basically sum up the value. Okay, this is the second reduce phase. All right, basically here mapper did not do anything other than just taking the input, making this first column as key, and that's all. Okay, so basically one sorting happened here where we concatenated the value such that the people who voted and whose worth is being counted, they all of that coming together, and then in the reduce phase, we break it down such that we give the value to B and C as 5, 5, C as 1, and so on. Right? Good? Is it clear to you? No? Anybody? Feel free to ask. This is a little twisted. And this is how a join is being done. Okay? So there are a few things you should note about this kind of join. First, for joining two tables, list 1 and list 2, we always need a column, a key on which we can join, because we are using, if you think about join, what do? We try to bring those data together which have got the same key. Okay, based on a column value, we've tried to bring all the data together, and that's what we did. But there are other kind of join also, such as the join which do not have any condition at all, right? That is not possible using this approach. Second, there are some join operations in databases, so where we say column 1 of first table should be greater than column 2 in the second table, right? That is not possible using this kind of approach. What should be the command for first reduce? This, you're right. Here we are talking about this reduce. It will be basically a small program which goes from the all the values from value 1 to end, and the value 0 is the number, the worth of each individual, and so on. Okay. So exact command and exact syntax, I will help you, and probably I'll be giving it on Monday. Okay, let me note it down. I haven't done it so far. Generally students do it, but I'll do it once. Okay, code for problem number 4. All right. So okay, Swati, do you want me to explain again? All right, great. So you all got it, or should I explain again once? Amit? Great, great. So, all right, now let's move on. So we talked about few problems, four different problem. You will have to create two separate jobs, okay, to solve it, because here this data is going to go back into database, and here not database, it is going to go into HDFS, and then again next Hadoop job will pick it up. Okay, where is the, so yeah, next Hadoop job will pick it up. So you always specify only single mapper. You cannot specify more than one mapper in a single chart. When I say more than one mapper, different code. Okay. Now question 2, can we automate the second reduce job? Good. This is a very good question. The way to go ahead with this kind of mechanism is you use a system like Uzi. We will be discussing this Uzi, where we will be basically chaining these things together the way we chain things in case of ant, Apache ant or Maven. Okay, so we'll be chaining these things together using something like an Uzi. All right. So Susant, you got the answer. You generally chain all of these things together, saying this is my first streaming job. Then we say that this is my second streaming job. It depends on the first case, and the folder where the first one is going to store is this one, and that same folder is going to be the input for the second streaming job. Okay, good. All right. So feel free to ask questions. It gives everybody else also, because everybody else also would be having the same question in the back of the mind. It's just that they are not asking. So, okay. So feel free to ask your question, even if whatever doubt you have, feel free to ask that. Okay. Great. So almost every problem can be solved by converting it into MapReduce. Almost, I said. There are few problems that cannot be solved, that should not be solved using MapReduce. Okay. Why? Because not all problems can be converted into a sorting problem. Okay. Not all problems can be readily converted into sorting problem. So there are few things you should avoid converting into MapReduce. First, if the job can be happily done using a single machine, do it. Do not overdo it just because you want to use MapReduce. And this is actually a common syndrome which I've seen. A lot of people, just for the small sake of using MapReduce, they do it. Okay, you do MapReduce on cluster for smaller input for two reasons. Either you want to test, or you are expecting the data to grow. You're expecting the data to grow after a certain point of time. Only then you say, let it run as MapReduce, even if the input is slow, because we know that the input is going to grow, and only then our jobs will keep on performing. All right. Second, when the computation depends on previously computed values. If your computation depends on previously computed values, then there is no point in going for MapReduce. It will be impossible to form a MapReduce logic for such problems. So it will be impossible to convert a Fibonacci series generation into a MapReduce problem. It's not possible to make it distributed so easily. And third kind of scenario is when you want to provide the search results to your end user. Okay, so whenever there is ad hoc searching involved, and full text indexing is okay, but is not really, MapReduce is not really great for that kind of solution. Okay, but can be done. MapReduce could be used for indexing, but may not be the best solution available. The last one is when your application is continuously reading data. Imagine your map is reading data from a network service. So for each line of the file, you might end up uh, connecting to the network and reading the data from there. Imagine there is a global cache from which you want to read the data all the time, and your algorithm depends on it. Now, for each line, your mapper is going to get executed and going to connect to this central global state. And that's when you will realize that your MapReduce is really, really bad at the performance. Okay. So when is the case when there is no other way than your mapper reading from a central machine, then probably you need to come up with a different approach altogether. All right. So those are the few cases where you should be avoiding to use MapReduce. All right. Now, a quick thumb rule for testing is: first, test on very small data. Second, test your mapper and reducer separately. And okay, streaming job can be tested easily. Okay, as I showed you there here. Okay, so the idea here is whenever you need immediate feedback of various sort, you should be avoiding using MapReduce. Okay, For doing indexing, for example, there are better solutions available than MapReduce. There are dedicated solution available. You should be using those. Okay, but ad hoc searching is something you should be avoiding. Okay, basically, a real time response. Okay, whenever you require real time response, you should not be using MapReduce, because all MapReduces are batch process. They go to the back end. It takes some time. There is a warm up time. There is a time where the job work gets distributed, and then there's a time when the work get reduced. And so MapReduce is essentially for huge data. It's not for small data. It's not good if you have 1 GB of data and you want to churn it. Okay, all right. Now, for testing, streaming job can be tested very easily. I'll show you this. Show you this. You see this command? Actually, this is good enough to test your MapReduce. Instead of calling MapReduce, you could take the input file which you're feeding to your streaming job, and then say cat my input file, then call the script which was your mapper, or the command which was your mapper, then call a command called sort. Okay, and then give it to reducer. Okay, and then save it in the output file. This is exactly what Hadoop also does internally. Okay, this will be being done on a local machine. All right, so this is like simplest way of testing your MapReduce job. This is the simplest way of testing your MapReduce job. Sounds good. And that's what makes streaming the next better choice, because you can quickly test, and then once you are confident about your mapper and reducer, you can move it to the network. Well, you can move the logic to MapReduce. Now the next one is that use MR unit. If you are in Java, you are working on Java, you can use MR unit. I'll show you a couple of examples. And fifth point is important. Most of the time when you are dealing with the big data, you will be doing the predictions actually. Lot of work which goes into big data involves predictions. Okay. So if you are working on predictions, devise solutions such that you can test them for their correctness. Okay. Devise solutions such that devise various kinds of techniques such that you can test your predictions. And how can you test a prediction? Okay, how can you test a prediction? You build an algorithm which is giving predictions on user behavior. How can you test such kind of thing? Yes, okay, with the small data set first. Okay, what else will you do? Let's say let's say you have got humongous data of people giving giving a prediction. I mean, you got humongous data of people's habit of watching movies. Okay, you have got three column data: movie ID, user ID, and how much a person liked that movie. You have got this data. Now you have to give predictions, and you build a really beautiful predictions algorithm, or you build a very nice simple average one, and it gives a prediction. Now, how do you test such kind of systems? Anybody? You want to predict that this user might like this movie this much, okay, based on this data. But how do you ensure that the algorithm you have come up with is really giving great results? Anybody? Compare with the past data. Exactly. So you divide your data by timeline into two halves, right? Yes, yes. So you divide these movie ratings into two halves based on the date on which people watched the movie and rated it. And first half you use for generating predictions and then compare the predictions with the second half. And then you do a sort of a distant computation saying how far are my recommendation for particular users. And then overall you come up with a number saying this is the distance between my predictions and the actual. Okay, so basically whenever you're predicting, doing a lot of predictions, you generally divide the data into two portions and then compare it with compare the second half with your predictions. And sometimes people actually can make the sample space like this. If you have got 100 records based on 90 records, you did the predictions and then compared your predictions with the with the actual data. Okay, and then you compute that how well were you in predicting the user's behavior, right? So that's a very important thumb rule. Okay, you have to come up with really really brilliant solution, otherwise the whole of your hard work will be ruined. You will not be of much use if you can't test it. All right. Now, in case you are working on Java, it's the way you write MapReduce is this. All right. Let me come up with this one again. This is how you write the code in Java. Okay, I'll just take it further. Now, assignment for today's session is code all your MapReduce problems in your favorite language. Okay, try to code it by yourself. This data is not there in HDFS. Create sample data for yourself and then test your MapReduce. Okay, whatever language you want to use, just use it and use the streaming way. Okay, use the streaming way to execute your scripts, and that should do. Now, second problem to you is based on the content from a no, test it in this one. You put it in HDFS. After testing locally, you put it on HDFS. Both. It's not. I mean, there's no harm in doing both. Yes, yes. The problems from session number 2. Please finish all of those in your favorite language and execute it using streaming. All right. All right. Now, next problem to you is that for each word, prepare top 5 recommendations. You must have been using the mobile phone, and when you type a word, it gives you the recommendation for the next word which is typed. Generally, which is generally typed after that word. If you type happy, you generally get happy birthday or new year or the marriage. So those are the suggestions which keyboard gives you in Android. I don't know about Apple, but that's how. So the way it is done is we download a lot of data, and using this data we prepare this kind of uh, a tuple system. Okay, we basically form a kind of recommendations beforehand, and then we give it to the UI so that it can give the recommendations. Okay, so basically the whole idea about giving recommendations is preparing this big hash map where key and the recommendations are there, and this is done by churning a lot of data. Okay, so you go to Wikipedia, download all of the data, try to churn it, and you should get a beautiful recommendation. Okay, how would you do that? So is the problem statement clear? Basically, given the Wikipedia kind of text, you have to find what is the next recommendation, basically the top 5 recommendations for commonly used words. Sounds good? No, only for Julie. No, this is for tomorrow's session. We'll be discussing it. The actual implementation, you can do it over the week because actual implementation is difficult. All right. You actual implementation you can do over the week, but conceptually you should be clear tomorrow. Okay. Then, right. And why? Because the approach which say Julie is suggesting, there are flaws in it. Think about it. There are flaws in it, and how, and that will make the basis for tomorrow's session. Okay. Yes, you can do it over the week. Yeah. All right. But make sure that you finish all of the map reduce over this week itself, because next weekend we are going to discuss something called pigletin and other things. All right. So, okay, I'm moving on now on to the session 4. This session is little smaller as compared to that one. Okay. All right. Okay. I want to just take you to few questions. All right. As a quick review of what we have learned, the data generated by mapper is given to reducer, and then it is sorted or shuffled, yes or no? Great, great, perfect, perfect. So the output of the mapper is first shuffled or sorted, and then reducers are called. Great. Let me see everybody's answers. Okay. So there are more questions coming up. So those who are sleeping, wake up, please. All right. So the mappers can only generate a single key value pair for input value. Is it correct? Yes, no? Are you sure? For each line, how many key value did we generate? For each line, our mapper generated how many key value in the word count example? No, no. For each line which was given to mapper in the word count, how many keys did our mapper generate? How many key values? More than one, right? So it depends on how we write our logic, but it can generate more than one, right? There is no such restriction. So the question is this: if each of our mapper is given, say, in word count example, each of our mapper is given a single line, right? Okay. Say for example, this is an online session, right? This was our input, and our word count mapper, how many keys can it generate for this input? One or multiple, right? That is the question actually. Okay. I think I have not framed the question correct. The mapper can only generate a single key value pair for an input. This is correct only, right? Is the question confusing? Because you all understand it correctly. All right. Because the other reason why I ask this question is those people who come from a background like Perl or other kind of languages, they have this impression that mapper only translates one key into another. It doesn't generate multiple keys. Similarly, there are other tools such as Apache Spark, which we'll be talking in session number 9, where the usual map is actually can only translate one value into another. It doesn't uh, eliminate or do something. Okay, now next question is, no, we can't say the input line because line will not be the always the input. Okay, that's not because we'll talking about this in detail. So mapper can generate as many key value pair as it wants for an input. Okay, now my next question to you is, let me just create another let me just create another question for you. Good, I got this one now. Can mapper not generate a key value pair for an input? Can mapper not generate any key value pair for an input value? Or is it, let me rephrase this. Is it necessary that a mapper always, actually I can phrase it better. A mapper always generates at least a key value pair. True or false? Okay, I'm sorry for creating confusion. So now this is my final question. So true or false? Yes, I'm asking if the output of the mapper is empty. Exactly. So yeah, the answer is false. The answer is false. Okay. Okay. All right. So it is up to your logic to generate a value or not. Okay. If your basically if your code was something like in the mapper you did not output anything. It is up to you completely whether your mapper gives any key value pair as output or not. It is completely up to you. Okay, if you want to eliminate some of the input values you can eliminate freely. You don't want to output at all. Okay, it is absolutely up to you. Right. For example, as Amit is saying, what if we don't want common words in our word count? Probably that would be an extension of this exercise. Say we have a lot of words. We don't want the common say is, am, are, the those common words we want to eliminate from the output. We can remove them easily. We can just uh, um, have our logic in mapper such that we don't output those words. Okay. Yeah. Then, Swati, then why would we have? No, we are not having them as a keys. We are talking about mapper. Okay. There's an input file. It's reading file. It's given a file or it's given a line by line. It's up to mapper whether it wants to generate one value, zero value, or nothing. A key, a one key value pair, two key value pairs, or a thousand key value pairs. It's absolutely up to your mapper. All right. Then the whole purpose of reducer is destroyed. What's with the reducer to do in such case where okay, so my question point here is one mapper may not generate for one line it may not generate the key or value. There is no pair generated, but for other input it might generate. So reducer might not be absolutely empty, and even if reducer is empty, why should there be a problem? So is it, should I explain again or is it clear? Yes, there's no problem at all. A reducer is okay, absolutely okay if there is no data provided to it. So the ma so mapper will output some data. I'm reading Megha's question. So mapper will output some data that may not be in the key value form. No, mapper will always generate in the form of key value form, but it may not be giving. It can give zero key value pair. It's as simple as that. It can give zero or more. For some lines in our word count example, we could have coded it that way that for some line, our mapper doesn't give any output at all. It just eats the input. But for some line, it gives more than one output, one key value pair. Okay. So let's say I give you an example. Okay. Let's say we coded our word count again. Okay. We modified our word count such that it counts the words which are not prepositions. Okay. So it encountered uh, this is a bird. Okay, this is a class of Hadoop. Okay, so this first line was fed to your mapper. Okay, and it became the first line became something of this sort. This one is one A1 class 1, right? But off did not generate any output at all. Why? Because we have coded our mapper such that it doesn't output in case of, okay, this is a class of few cases of Hadoop. Okay, here it will generate few one cases one, and off is skipped anyway, and one, right? So basically it is up to your mapper to generate the output. All right, great. So note that, because that's where we make a mistake. We get under the impression that it is we are forced to generate the output. And remember that it is actually true for a lot of languages. The mapper, the actual definition of mapper which came from Perl, where we apply a function on each element of an array. So if you have an array and you want to compute the square root of all the elements, so we say apply my function on each of the elements, apply our square root function on each of the element of an array, right? So that was the definition of map in the traditional sense. Amit, should I go ahead now? Now, next question to you. Oh, okay. Okay. So by default, there is only one reducer in case of streaming job. As we saw it, right? How many reducers were there by default? Okay. So basically, your okay, let me explain this again. So when there are two ways to look at two definitions. One, how many times your reduce method will be called. That will be many times. But the actual number of reducers when we say is at only one by default, because it's being run only on one machine. But the function call, the method call of your script, which is reduce, is going to be many times. Yes, you can have. Great. By default, there is a single reducer job, but it can be split by specifying these options as we demonstrated. Okay. Now, quick questions to you. What is the role of job tracker? Perfect, perfect. So we are all on the same page. Excellent. The map logic is executed preferably on the nodes that have the required data. Okay, good. Let me rephrase the question now. Okay, let me duplicate the slide. Okay, now let me just change it a bit. Yes, good, 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 good. All right, so these are great answers. Now, next, moving on. Now, this is something which I would like to discuss. The whole of HDFS block available on a node is fed to the mapper. Yes or no? Correct. Correct. The answer is no. The input is split using input splits. We will discuss this in tomorrow's session. Okay. Now, this is okay. So Abhinav, if in case you missed the question, right, we'll just go through the one which is located in the in the my courses. Okay, you can go through these things again. Question number slide. The whole of the answer is no. Okay, the answer is no. Don't worry about this. Here, okay. So let me see. Where does the Hadoop store the result of the reducer? Excellent. Excellent. So answer is HDFS. No, it wasn't in the file system. You remember I said every time Hadoop fs cat, right? When we saw on the from the browser here, we were looking at the data here. If you see, this is HDFS. This is HDFS, the part 1, part 2 and all. This is HDFS. And the way we were working on this is using HDFS fs minus ls and all. Yeah. So both the input and output both is in HDFS. No, Megha, actually the data is in the HDF. Okay, are you answering Julie's question? Okay, good. All right, next question is, hmm, let me put a question mark so that I can differentiate. So where does Hadoop store the intermediate data such as output of the MapReduce task? Mhm. I think I should keep one more option called it's complicated. Okay. The fourth option I should keep it as it's complicated. Okay. And okay, can it be either memory or HDFS? Okay, interesting. Okay, no, actually, the intermediate data is actually stored locally on each machines because this intermediate data is of no use after this task finishes. Okay, therefore, there is no point in having that replication, blah blah blah, onto HDFS for this local data. All right. Therefore, the intermediate data, such that each of the map nodes keep the data locally. Some of the data is actually in memory, as Seema pointed it out. Some of it is in memory, but always it's flushed into the local file system. Okay. While the other tools such as Spark and other tools try to keep the intermediate data in the memory for the computational reasons. Local file system, as in on each node, the local file system, there will be a temporary folder where it will be created and then destroyed. Okay. Okay. So you say it loud, whatever is the question, because so HDFS is Hadoop distributed file system, which runs on multiple systems. So I'll show you this. You see this folder here, just to give you a practical use case. You see, here we have this folder. Now, whether I'm logged in onto, say, I'm logging into Hadoop 4.nobigdata.com. All right. So this where I am. This is I'm on Hadoop 1. If I say ls, the folder structure is different. Now I'm logging into Hadoop 4. It's a different machine altogether. Okay. But if I do same command, Hadoop fsls, I'll get the same folder structure. See, I got the same data. And if I say ls, it doesn't even have my asgiri folder, while this one has my asgiri folder. Okay, so there is a local file system of each machine, and then there is another file system, HDFS, which we created in our first session. Do you remember that it has got blocks and everything? It has got multiple data nodes. It has got name node. That is HDFS. So we have say four machines right now: Hadoop 1, Hadoop 3, Hadoop 2, Hadoop 3, and Hadoop 4. Those machines have their own local file system. Some of this file system is donated or reserved for for the data node which is running on all of these four nodes, and that all those data nodes combined together are giving you the HDFS as you see it. Okay, and the way you interact with HDFS is using Hadoop FSLS, and all of the data input and output of MapReduce, the overall MapReduce job is through the HDFS. So did I help in any way, Julie, to explain, or do I add more to the confusion? Yes. In this case, whenever I say that I'm talking about local file system, it is the data nodes file system. While in some cases, the local file system is my own. Actually, whenever I'm referring to the local file system, I'm referring to Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4 locally, the data nodes. Okay. To avoid the complete confusion, actually, in case there was one more person, there were many people who got confused with these many file systems. So I actually drew a diagram, and you can have a look at the diagram. I've tried to explain using this diagram. I myself posted the question, and this will actually clear up the way you visualize the these systems. Okay. All right. So go through that, and let me just go through the questions, and we finish the session. All right. These are very genuine questions. Everybody would have these questions. It took me some time to fiddling around and then got comfortable with that. Okay. So the more you fiddle around with the servers, the more you will get comfortable. All right. Any other question? Did I miss anybody's question? Can you just post your question again in case I missed your question? And if not, then we call it a day. All right. All right. Thank you very much. I thoroughly enjoyed your questions. I hope you liked it. Thank you, Megha. And yeah. So after this session, you'll get a questionnaire. Please respond to the questions. Okay. Probably Anjana would be sending the questions. Please respond it. Okay. Thank you very much. Looking forward to see you tomorrow again. Bye bye. Have a good day.